7.4, partial fractions.
The actual full title of this is partial fraction decomposition.
Here's what this means, because it's kind of important. Like sometimes, like if you don't know why we're doing this, then that's frustrating, right?
Right, I agree.
The idea is, how if you have like two separate fractions, like you get common denominators.
Add them up.
Yeah.
So that would be 3 over 6 plus 2 over 6, Mrs. K. Steve.
And then you get 5 over 6.
Right.
You just combine those fractions. Well, when you do it with algebra and more things that are more complicated, we can still, even with like x's on the bottom, we can still get a common denominator and add them together. But what if we have a fraction and we want to split it up into the smaller fractions?
And I'll tell you where this is going to benefit you is actually next year in your calculus courses, because there comes a time when you have to integrate.
Yep, fancy word.
Fancy word that you'll learn all about next year. And you don't want to integrate 3x minus 4 over x squared minus 2x. I don't want to do that. However,
if you can split it up into
the smaller fractions,
it's way easier.
Super simple, actually. Okay. So this is actually a skill that will come in handy next year for almost all of you.
And really, the longer you go in math, the more it comes up all the time.
It's spoken by the lady who's in graduate school for math.
Absolutely. So here's some general rules, and these may not make a ton of sense, but when you come back to this page while you're working the assignment or during the notes, you should see that these things are checking off. So the degree in the numerator needs to be less than the degree in the denominator. So see how this is an x to the first and this is an x squared? That means we're good to go. If they were the same, or if the top is bigger, we have to start off by using long division to divide things out. And then we'll end up probably having to do partial fraction decomposition later on.
Right.
The first step, actually, after making sure that you don't need to use long division, is to factor the denominator as completely as possible, because that's what's going to give us the denominators.
That'll give you the bottom pieces. And so you're going to have to maybe dig into all your different bags of tricks for factoring out your denominator. But it should factor to something that you would recognize. Like there shouldn't be a square root running around or something like that.
Right. It should be pretty simple algebraic factoring. And we will get sometimes this term, which we ran into at the beginning of the year, this term called irreducible quadratic.
Something like x squared plus 1. Yeah. So if we have x squared plus 1 and I go factor that,
I can't. Yeah. I can't factor that. You shouldn't be able to either.
If you factor it, you've done something incorrect.
And you could put a minus 1 here, and then it would be factorable, but x squared plus 1 you can't factor. This is considered
Listen to me. Go ahead and write this down real quick. X squared plus 1 equals x plus 1 times x plus 1. Okay, if you write this down, a puppy dies. Because it's not true.
This is what it equals.
That's what that equals.
Not the same thing.
That's not the same thing. Okay, we don't want to kill puppies today.
No. So when you get to something you can't reduce anymore, it may be a quadratic.
It'll work out.
Fine.
It'll all
we'll
work
deal
out.
With it.
Okay.
Each factor will be in the denominator of a partial fraction. All numerators in the partial need to be 1 degree less than the denominator. We'll show you what that means. You can check by graphing if you take what you originally have. So if you take this, and that's like y1, and then you take this and graph it as y2, they should be the same graph.
Like identical. And you can even check that in the table of points. They shouldn't even be close. They should be the same.
Right. So how about we get started?
Let's do. I like that plan.
Okay, so example 1, we're not even going to solve this. We're just going to set up our partial fraction decomposition.
Okay.
So what that looks like is that we take this denominator and we break it up into parts.
There's 3 parts because there's 3 things.
Right. But it's a little trickier than that because
the x cubed.
The x is cubed.
Yes.
So what you do is this factor at the beginning is x.
Right.
Okay, and
x cubed factors.
We have that 3 times.
Right. So you have to actually write down the factors of x cubed, and that can be a toughie to try and remember.
Whenever that happens, that you have something to a power, you end up you have to write the factor, and then you have to write
the next power
squared, and then
the final.
Okay, and that part's kind of tricky, and we'll come back and we'll have that happen again later. So you'll see it again. Our next factor is x plus 3.
Right. That's easy to see.
And our next one is x squared plus 1.
Which is an irreducible quadratic, so it's okay.
Yeah. Now, the rule is that on top here, we're going to put variables, and it has to be 1 degree less than the factor we're talking about. So this x means that we won't have an x on top. That's 1 degree less.
Right.
We need something to represent a number. So typically we go in alphabetical order.
Right. Just start with A. Right.
This,
and use capital letters too, because
that's just
it's easier to distinguish. Like if you have an X and a Y running around at some point, capital letters are easy to distinguish.
Right. X squared is also going to get a letter, okay? Because it's X and it's to some power. So
right.
And then X cubed is going to get a letter.
Those are right. But again, because it's not an irreducible quadratic.
Right. And then X plus 3, that's linear. So
he just gets 1 letter.
X squared plus 1 is a quadratic, which means we need something linear on top.
Right. So
linear,
one degree less.
Yeah. Linear means we have an X. So what we're going to do, because I'm just, again, continuing going in alphabetical order, we're going to use EX plus F. Because think about it. What's the equation of a line?
MX plus B.
Right. So we're just going to, and we could use, well, we can't use B, but so EX plus F.
Right.
Now, solving this would be just terrible.
Well, maybe not terrible, but it would require quite a few steps.
Yeah, so this is just us setting it up. You've actually now seen all of the tricks to setting up a partial fraction decomposition. And now after this point, we're actually going to start solving them.
That sounds brilliant.
Okay. All right, we're actually going to show 2 ways to do this. So this is going to be the first way.
Okay, sounds great.
But they both start off the same way. We need to factor the bottom.
That was step number 1 from slide 1, if you'll remember.
Notice that it's a smaller degree on top than on the bottom, so let's
We're good
factor.
to go.
So 1 multiplies to get negative 15, that adds to get negative 2.
Oh, you were asking me. So that's going to be 5 and 3. Negative 5 plus positive 3 gets me negative 2. Sorry.
Okay, so what we're going to do is we're going to use those as our denominators.
Right. I was trying to figure out why you weren't writing anything.
Because I was asking you. And then on top, since they're both linear, we're going to put A and B.
That's all. Now, that's all there is to that setup. Now, each factor has its own fraction.
Now, we're going to pretend like we're trying to get common denominators on this side.
Okay, that's a good plan.
The way you get common denominators, this is x minus 5, and we're trying to basically get back to this denominator. So what is it missing? It's missing x plus 3.
Right.
So we're going to multiply the top and the bottom by x plus 3.
Okay.
Right?
Yes.
And then this one needs an x minus 5. It needs
x plus 5, x minus 5, x minus 5. So that way we can add them up.
Right.
Because you can't add fractions unless the denominators match.
Right. Now that we have all the same denominators on both sides of the equal sign, we're going to drop out the denominators.
Because when you add fractions together, you don't mess with the denominators. You just add the numerators. So we need to make sure that the numerators are equal. So here we go, 5x minus 1. And
I just rewrote
there you
what
go.
our numerators.
That's all the numerators are. So there you go.
The first strategy we're going to use is we're going to pick values for x to plug in so that we can solve a and b.
So we're going to pick a really specific value of x, though.
Right. Because,
with intention.
Yes, there are specific numbers that will be super helpful here because remember that 0 times anything is 0.
Yes. It's one of my favorite properties in math.
Yeah, so think about it. What value could I put right here for x that would make this parentheses be 0?
Pi.
No.
Oh. Negative 3. I was
negative
just
3,
kidding.
right? If
I was
you
close.
put in negative 3, negative 3 plus 3 is 0, so that'll cancel that out. So we're going to start off by plugging in a negative 3.
For all the x's. So if we say
x's.
x equals negative 3, everywhere we see x, we put negative 3 in. Now what's really fun about this is one of our variables goes away.
Yes. I like to make a little sound effect because this is 0, so psh, psh, goes away.
Was that like lightsaber swords?
Kind of like a lightsaber exploding kind of a thing.
Yeah,
5 times negative 3 is negative 15.
Let me try now.
Minus 1. But we didn't actually mark anything out.
Oh, okay.
So negative 16. And then negative 3 plus a negative 5, that's negative 8. So that's
times
negative
b.
8b.
Now look, we went from this super complicated precalculus problem all the way down to a simple algebra 1 single step problem.
Divide by negative 8, 2 equals b.
There you go.
So we know the numerator of this fraction. Now I need to find the other one. So,
and it's really important, too, that 2 stays where the b is. And so an easy mistake to make is that you just go in and toss your numbers back into your problem.
Yeah, you don't want to put 2 on top of the first fraction.
Yeah.
The other number that's helpful here then now is what if we want to get rid of this one instead? What number would we put in for x?
5. Put a 5 in there.
Put it in.
Put in the 5.
So everywhere that x is, we're going to put in a 5.
Now, the B part goes away because 0 times anything is 0, which I've already said is one of my favorite
Right, you want to
properties.
make the sound? Ready?
Yeah. Was it as good as yours?
Pretty good.
Okay.
Pretty good. 5 times 5 is 25, minus 1 is 24. 5 plus 3 is 8, so that's 8a.
And again, difficult precalculus problem, single step algebra 1 problem. And boomo.
So to write the answer now, we come back to what this was, but we fill in a and b. So
Right.
a is 3, that's over x minus 5. B is 2, which is over x plus 3. And that's our answer. Now, if you had written these in the opposite order, then you just would have gotten
Right.
2 over x plus 3 over x minus 5,
yeah.
which is the same thing.
That's right. The 3 just needs to go over the x plus 5, the 2 over the other one. Doesn't matter what
3
the...
x minus 5.
Right.
Yes.
Doesn't matter the order.
Right.
Right.
All right, so step number 1, factor the denominator.
Step number 1, check and make sure the numerator is
right.
less degree.
And it is. X
Yeah.
squared is smaller than x cubed. So
Right, every time.
Second step. We can take an x out of all 3 of these. So let's do that.
Ooh, that's going to factor. I can already tell.
It is. So that factors into x minus 2 times x minus 2.
Yes.
Which is really x minus 2 squared.
You know what? But for partial fraction decomposition, it might help if you just went ahead and write it as x minus 2 times x minus 2.
It might.
Because when we change it, each piece has to get its own.
But the second piece is going to be x minus 2 squared, not just x minus 2.
Well, okay, you're right. Okay.
So we have a linear factor that's going to have x on the
I
bottom.
agree with you on that, by
Okay.
the way. Yes.
And then x minus 2 needs to be represented,
Right.
but also we need to represent
The degree
x minus 2 squared.
Yeah. Every level of degree has to be represented when you do this.
Right. So these are going to just be A, B, and C.
Mm-hmm.
And now our step is to basically figure out what to multiply by to get common denominators. So this x is missing x minus 2 squared.
Right. Top and bottom because
We're getting common denominators.
common denominators.
This is missing an x and an x minus 2.
Missing one of each. Yep. One of each, Mrs. K. Steve.
This one is just missing the
The
x.
X. Yeah, there you go. That guy's almost the easiest to work with, actually.
Right. Totally. Okay, so now
So-
just taking the numerators, we have negative x squared plus 2x plus 4.
And we can set it equal to the numerator on the other side, following all our rules of fractions. So,
Yeah, I said we were going to show the other way, but I think the other way would be more difficult on this one. So let's just save
Okay.
it.
All right,
Let's
no
do
problem.
what we just did. So
Okay.
what are some numbers that are helpful for us to plug in here?
one of the numbers that would really be ideal here would be a 2.
A
because
2,
2
right.
minus 2 is 0.
zero, so-
And not only that, it takes out the A and B term when you do that. So it leaves us with C.
Yes, that's like the ideal situation.
Right.
So put a 2 everywhere where x is.
And remember, when you put a 2 in for x, you're eliminating one of our possible variables. Because we're saying, hey, x is 2. That's what x is going to be. Is that second lunch bell?
Yeah. Okay, so
A and B are,
A and B are
are
going
gone.
to go away.
Yeah.
So
And at any time you can eliminate 2 of those terms on your first step,
that's a great
that's a
thing to do.
great thing
Yeah.
to do, okay?
So 2 squared is 4, that's negative 4. Plus 4, that's 0. So we get 4 equals
2C.
2c. So you divide both sides
To
by 2.
see or not to see?
And you get c equals 2. Now there's another number that we can plug in that will also be helpful here to get rid of some things, and that's going to be 0.
0 right there, yep.
So
But now we know what C is, so we can actually put a 2 there if we want.
if we want to,
It
and
doesn't matter because 2
Yeah.
times 0 will be 0, so.
all right. So
That's a lot of writing.
yeah, it is. So this time these two go away, And we're left with, this will just be 4 on this side again. Oh, I've picked a slightly different color.
Oh, so that's a little bit of
An orangish.
Yeah,
Okay,
orangey. Go
sorry.
back to maraschino.
Maraschino. Okay, so negative 2 squared is
4.
4.
4a.
4a. So you divide that, and that gives us a equals 1.
Okay, now we got 2 of them. Now, here's where it gets really weird.
Right.
We get to pick x, right?
Right.
And we already know 2 of the things we're looking for, right?
Right.
So really, that just leaves one thing left to find.
We just need b.
We just need b.
So basically, we were allowed to pick anything we wanted to here when we picked 2 and 0, but we picked those because we knew they would work out well. Now we still have one more variable. We need to pick a number. There's not a good one that works.
Nothing's going to make a 0 or clean it up nice.
Right, so we just need to pick any old one, and I like 1.
I mean, if you have to pick a number, 1 works really great because...
If we hadn't already picked 0, I would say to pick 0.
I agree.
But let's pick 1.
Okay.
So...
Now, while Mrs. Stevenson's filling this one in, we're just going to put 1 in for all of the x's, and then... Since we know that C is 2 and A is 1, we put those in also.
So you do have to pay attention.
Got to pay attention. We're solving this for a purpose. I mean, we need those values to help us. I hope you have enough room there, Mrs. K. Steve.
I got it. Don't even worry.
You're pretty
about
amazing.
it.
So
thanks. So now nothing cancels out. We've just got a bunch of mathy stuff to do.
Yeah.
Negative 1 plus 2 plus 4. That's 5.
5.
This is
1.
negative 1 squared, which is 1 times 1 is 1.
So 1 plus.
This is negative 1 times b.
So
that's
actually 1 minus.
B.
Oh, the whole thing went away.
Oh, I think I accidentally double clicked.
Oh, you double clicked.
2 times 1
plus
is,
2.
So that's 5.
And so look, now again, complicated pre-calc problem boils down to a fairly simple algebra 1 problem there.
So subtract the 3 and get 2 equals negative b, so b should equal negative 2.
Positive negative 2. Positive b equals negative 2. That's what I was going to say.
Okay, and then we come back up here and fill in a, b, and c. So a was 1, so that's 1 over x plus
b, which is negative 2.
So we can put negative 2 on top,
right,
or
you can put it there. Yes.
2. And then c is 2.
I just want to say, I don't know if you can hear this, but one of my favorite songs by Sigur Rós is playing right now, Saglapur. It's just really cool. It's a complicated problem. There's a little levity.
Okay. So, and just to reiterate, we just took this and we're saying that if you took these 3 fractions and tried to get common denominators and add them together,
you're going to get what we originally started with.
Plus 2x plus 4.
Hey, and a great way to check yourself
is to do just that. No,
or
to
graph it. Graph it, easiest by far.
Yeah.
All right, so we're going to find the partial fraction decomposition.
Yes, we are.
And real quick, check C's on the numerator.
Yeah, so the numerator has a smaller degree than the denominator, so we're good to go.
Start her up.
There's 4 things there, so
all right,
let's factor by grouping. Factor by grouping. That's not an option.
Oh.
Take out what these two have in common, which is x squared, and leaves you with x minus 1. What these have in common is 1.
Yeah. Oh.
Right?
Wow, that's
so
tricky.
So these are in common, the x minus 1s, and they leave you
x
with
squared plus 1. Now,
there's that irreducible quadratic.
We've seen that exact one before today.
We have. So this is going to be a over x minus 1 plus bx plus c over x squared plus 1.
Right.
Okay, so in this case, this is one where it may be better to try it the other way.
Try other one, okay.
And the way that really makes an issue is the irreducible quadratic, because before now we've been picking things basically that ended up giving us zeros on the bottom of these.
Right.
If you look back,
right.
X squared plus 1 doesn't give you a 0. If you try to solve that, there's not a number you plug in there that cancels it out. Well, right, there's not a real number. So let's go ahead and start it off the same way. Our common denominators.
Same starting, different ending.
Right.
Okay. So again, common denominator. Now, the other thing that you may notice, since we've done a few of these now, is basically what we're doing is multiplying both sides of this equation by that common denominator. because that's what you're left with when it's
Right.
all said and done. So if you can see that that's what's happening, I feel like it's okay for you to go ahead and go there. Is that appropriate?
Yeah.
Okay. So here we go. We're setting this guy up.
Now we're going to show you a slightly different technique here.
Right.
Okay. So that technique requires us to start off by actually distributing or foiling on the right side.
All the stuff out, yes.
So this isn't going to change for now.
No, the left-hand side stays the same, but the right-hand side now is we're going to take a couple steps by FOIL and combining terms that are the same. Now you'll have to really pay attention because they're going to look different and there may or may not be anything that combines.
Right.
So we'll have to see.
And this
Okay, looks
foiling
good.
may seem difficult. Just take it a step at a time. Bx times x would be bx squared. Bx times -1 is negative bx. C times x is cx. C times -1 is negative c.
All right, looks good.
Okay, so what we're going to do is we're going to group these together by what would be like terms, like kind of what you were
Right.
saying. If
So-
these were actual numbers, x squared and x squared would add together.
We would add, right.
And so what happens is that together those would make a plus b times x squared.
Right.
Think about it. If this was 2x squared plus 3x squared, that gives you
5x
2,
squared.
which is 2 plus 3
Times
times
x
x
squared.
squared.
Right.
That's what we're doing is we're going to put the x squareds together, add our like terms. Now let's group our x's together. So we're going to put,
Negative b plus c.
because whatever those numbers
Right.
are, that's what would
That's
add
what it would
together.
add up.
And then a and minus c, and they don't really have anything.
But we should probably put them in parentheses anyway
Yeah.
for what we're going to
We
do.
don't have to, but
No.
we're saying this is our numbers that are
Right.
left over that don't have an x or an x squared. And that still equals x,
X squared plus 4x plus 1.
Now, this is kind of the tricky part to understand. In order for this to be a true equality,
Which we're saying it's an equality because of the equal sign.
right, that means that x squared has to equal a plus b times x squared.
Right. In other words, a plus b has to equal 1.
The coefficient of this,
Right.
which is 1. So 1 equals a plus b.
Okay. Same thing now for the
For
4x
x's,
part, for
okay?
the x's.
So 4x has to equal negative b plus c times x, which means 4 has to equal negative b plus
Right.
c. And then 1 has to equal just our number now, which actually we don't have to change
Right,
that
there's
at all.
nothing that changes. So 1 equals a minus c.
Now, this is a system of 3 variables with
Three
3
equations.
unknowns, or 3 equations,
Three
yeah.
equations.
And so we can solve this by elimination, substitution, plugging into your calculator.
Make a matrix,
Whatever you want to do. So basically, let's solve this one for A. Let's see how that works out. So subtract the B over. And let's plug that in down here.
Sure.
So that gives us, let's subtract the 1 over, that gives us 0 equals negative b plus, not plus,
minus c.
c.
Which we can combine with the middle equation.
Right, which is why, that's where we were going with that. It's kind of tricky when you have 3 equations,
And
but
2
there are only
variables.
2 variables in each. So 4 equals negative b plus c. The c's cancel. We get 4 equals negative 2b.
So b is negative 2.
Okay, and
So
now,
that's different. Now everywhere
it's
we see
easy.
b. Now,
Right.
Yeah, now it's no problem.
because a equals 1 minus b.
Negative 2.
Which is negative 2. So 1 plus 2, which is 3.
Right. That's
And
your
then you can go either direction here.
A. You
like
pick it for c.
1 equals a, which is 3,
Minus
minus
c.
c. So you subtract the 3 over and get negative 2, and then divide by negative 1.
So c equals 2.
Okay, so then we just plug these back in up here. This is, what was a? 3 over
Yes.
x minus 1 plus
bx, which is
2
negative 2x.
x plus c, which is 2.
Right. And I would leave the negative 2x alone in this case. I wouldn't put the negative in front because that messes up everything else.
X squared plus 1.
Right.
I'm not actually, I wasn't on the right problem there whenever I wrote that.
Well, all that looks good to me. So,
So yeah, sure, why not?
hey, now one other thing that you could do as well, you know, if you didn't see elimination right off the bat, you could set up a matrix
in your calculator.
On your calculator with A, B, and C.
1, 1, 0, 1.
Right.
0, -1, 1,
Right.
4.
Right.
1, 0, -1, 1.
Right.
Yeah.
Okay, there you go.
Step 1, check to see if we need to do long division.
Oh,
this could be
I
tricky
see long
on this
division.
one. This could be tricky on this one because this is x cubed on top.
Did you
X
just
squared,
ho me?
X squared is x to the 4th.
Which I knew that. I was just tricking you guys.
Why would you do that?
Because it's, dang it, sorry, I kicked the camera.
Earthquake.
Yeah, no,
Okay.
another one.
Okay, so x squared plus 1 is an irreducible quadratic.
Right.
We keep seeing x squared plus 1 in particular.
He's pretty easy to spot. So,
Okay.
and you need both versions of this now, both
Right.
degrees.
So now we need x squared plus 1.
Squared. And but
CX
plus D.
plus-
That doesn't change the top though.
Yeah.
You still just have just a linear thing on the top.
Okay, so now we need a common denominator, which actually might scare you at first, but you only have to multiply the first one by the x squared plus 1. The second one already has the
got 'em
denominator that we want.
It's good to go.
G to G, good to go. Okay, so 2x cubed minus x squared plus 5x. And you might be thinking, oh, I can factor an x out of that. We don't need to.
Yeah,
We don't need to
there's
do
no
anything
point.
to the numerator.
Right.
So we've got ax plus b times x squared plus 1 plus cx plus d. Now, again, we've got irreducible quadratics. Unless you just want to sit and have to plug in a whole bunch of different x values randomly, it really is a better way to go to foil
the
this
thing
out
out.
and then match up with your coefficients.
Right.
So,
And it might even work out that one of those coefficients, one of those
might be 0.
might be 0,
And that's
or,
okay.
or it might be an actual number right off the bat that we'll be able to see.
Right. So
So.
ax times x squared is ax squared.
Ax cubed.
Cubed, thank you. Ax times 1 is
AX.
ax. B
Yeah,
times x squared.
bx
is-
squared. Plus b. Sorry, my bad talking has rubbed off on you, Mrs. K. Steve. I'm sorry about that.
It's all right. Okay, now we're going to match things up. So with 2x cubed goes
My-
all of the x cubes.
Right. So.
But there's only one.
Oh, looky there.
And
Son
so,
of a gun.
So that means that 2 has to equal a.
We know that now, so we can use that to our advantage
Yeah.
later. We're going to use our powers for good, people.
Yeah. So now negative x squared has to equal all of the things that have x squareds, which is
Ooh,
only...
just a b. Use your powers for good.
So negative 1 equals b. Okay.
Does it get even better?
No, it doesn't.
Oh.
Now we're going to have to... Well, I mean, it's still not a bad problem.
Okay.
So 5x equals all the things with x's. So ax and cx, those will add together to give us a plus c.
Hey, but we know what a is. A is 2.
Right. So we have 5 equals a plus c, but we know a, right?
A is 2,
okay.
right.
Yeah.
So
A
2
is
plus c.
2 plus c, so c is
3.
bam. Okay. And now we don't have another thing here, which means what are our numbers going to have to equal?
0, because there's no coefficient.
Yeah,
there's
there
no
is
constant.
There is no normal number. And the same thing would happen if there was no x's, that would have a 0.
Right.
Or if there was no x squareds, that would get the 0.
Hey, if you don't have any chicken nuggets left when you get done eating,
Then
how many chicken nuggets do you have left?
5.
0.
0.
0.
Right, yeah.
So
0 equals b plus d, but we know that b is negative 1.
Right.
So negative 1 plus d equals 0. You add the 1.
d equals 1. Bam!
I mean, that was actually probably one of the quickest problems
That-
that we've done today.
That was a fast problem right there.
So
Super
a is
fast.
2 and b is negative 1. So that's our first one. C is
Wow, that was really weird. My phone made a funny noise. Sorry.
plus d, which is 1. X squared plus 1 squared.
There you go. Graph both those puppies. Check them out.
If you want.